Welcome back, dear explorer. I trust you've managed to get some rest after yesterday's, unexpected musical interlude. It appears someone out there in the vast cosmos has a sense of humor. A rickroll, as you Earthlings call it. Quite the antique prank, but I suppose humor is scarce in the vacuum of space. Anyway, it's time to get back to business, don't you think? The endless void isn't going to explore itself. On the docket for today, we have some interesting challenges lined up. To enhance the security of our ship's control panel, we will be utilizing our keypad. We're going to set a personal identification number, or PIN. This will prevent any mischievous extraterrestrial beings from fiddling with our control panel, or a future you pranking the past you. Time gets pretty wibbly-wobbly in space, you know. Additionally, we're going to make use of our passive buzzer to provide auditory feedback. This will help ensure that each key press gets the recognition it deserves and gives you, the user, feedback that an input has been registered. Well then, let's not delay any longer, Explorer. Let's dive in and ensure our systems are secure and interactive. Onward to the adventure! Ah, the beauty of continuity, dear Explorer. You see, the marvel of the universe is that it remains, for the most part, constant. Stars keep burning, planets keep spinning, and black holes, well, they continue being quite black and very hole-ish. Likewise, your wiring from yesterday remains perfectly suited for today's exploits. No need for new knots or wires to detangle. The cosmos has blessed us with a touch of simplicity today. So, we will bypass the wiring stage this time and leap directly into the vast and mysterious world of code. Brace yourself, Explorer, because today we dive headfirst into the celestial sea of ones and zeros. Let's embark on this code adventure, shall we? Life as an interstellar explorer may feel solitary, and indeed, it mostly is. However, one mustn't overlook the odd chance of bumping into unwelcome guests. After all, space isn't a private garden. It's a vast, unending sea teeming with possibilities and, yes, even potential space pirates. Don't look so shocked. It's not all fun and games out here. It'd be awfully dreadful if your ship's autopilot got hijacked mere moments after finally getting out of this planet's atmosphere. You're welcome to get stuck again, but I think I'll pass. Thank you. So, with that merry thought, we turn our attention to an essential system in our spacecraft, the security system. Today, we'll give that a nice little upgrade. We're going to add a personal identification number, or PIN, to our control panel. Consider our two-dimensional array from 2 days back, our beautiful little keypad with all those character inputs. Now, let's assign 2 of those keys for some functional fun. One key, an asterisk, will let us change the PIN. The other key, a pound symbol, will be our magic access key. Press that, punch in the correct PIN, and there you have it. The control panel is all yours. Speaking of pins, we need a default one, don't we? Something nice and simple to start with. How about 0000? And before you roll your eyes, remember, this will be changed immediately after. A quick note on system integrity. You see, we only want to allow PIN changes if the user, which in this case is you, already knows the PIN. A little layer of security, if you will. So we'll split this logic into a separate function to prevent duplication. Remember our discussion about functions? Yes, we created one using void because we didn't need it to return anything. Well, that is no longer the case. We need to know if the PIN was correct or not. So, let's switch void with bool. When we call this function, it will now return a Boolean value, either true if the PIN is correct or false if it is not. We also need to make sure to add the proper return statements as well where needed. And don't worry about the function going on a spree of calculations. Once it hits return, it jumps right back from where it was called. I've got a line-by-line breakdown of today's code waiting for you. I advise you take a look. It's packed with knowledge and could very well be your key to survival in this cosmic expanse. Off you go then, Explorer. Please make your way over to the instruction material that I was able to gather cached on your computer. I've also added it to your mission resources for future reference, should you so need it.
All right, welcome back to day 13 of the 30 Days Lost in Space Adventure Kit Code Explanations. Today we're going to be building on what we had yesterday, where we added in the buzzer to our little keypad thing and made us essentially like a little piano to make sure that the buzzer and the keypad were both functioning properly. I hope you had fun with the little bonus project, and I hope we got you there. The next thing we're going to be doing is we're going to be adding a little bit of extra security to your control panel. As you know, there's currently no security, meaning there's no password, so if anyone wanted to access your ship as soon as you got into space, you could probably guarantee that somebody would likely remotely get into your machine, even if you didn't want them to. So to prevent this, we're going to go in and we're going to add the functionality for a pin unlock to our lander's control panel. Now, the new concepts that we'll be talking about today are the following two things. One is what a return function is. Basically, at the end of a function, we've been using void, which returns, well, void, which is essentially nothing. We're not returning anything at the end of there. So when we call that function, it just executes some code and then hops back. And that's all that void does. But a return statement at the end is a different way to do functions, which will essentially return a value, such as, if an integer of 10 or a Boolean of true or false, but whatever we end up deciding we want it to do, we'll be going over that today. And as well as the new type which I just mentioned, Boolean, which is, you can think of it as it only has two states. It is either 0 or it's 1, and there's no other scenario that it can be anything else. It is just 0 or 1. You can think of it as false or true, or yes or no, but the only two values you can save it as is true or false, and that's it. If we hop down here, we'll see the following. Obviously, we've gone over this, and gone over all of this up until, well, up to here. This is all stuff from yesterday where we defined the keypad, create the keypad object, and obviously we have it mapped to certain buzzer pins and etc. later on. For simplicity's sake, we've actually removed the tone to the array, and we're just going to have it hard-coded for different success and failure pin tones later on in the code. If we go down to setup, we're going to set the buzzer pin as an output, and then we're going to serial begin 9600, talking over the serial monitor, and obviously just a quick tiny little delay before displaying the prompt, just to let us know, hey, by the way, if you want to create a new pin, because we're going to start with the assumption that there is no pin currently in the system. As you can see here, we've defined, this is the only new value we've defined at the top. Constant byte pin length is going to be equal to 4, so we're requiring the pin to be 4 numbers or characters. And down here, we're having the pin set initially to just 0, 0, 0, 0. Press the star key, which is on the keypad, that bottom left key, to enter a new pin, or this to access the system. And that's going to be at the very, very beginning of setup. After that, you can guess where we go. Right to the beginning of loop. We go to the beginning of loop and we say, hey, let's check what key is on here. Let's wait until we get a key press. And until a key is pressed, obviously this is a wait for key. I'm going to guess if I go into this function inside of the library, we'll find that we have a while key is not being pressed. We just continue to loop forever and ever endlessly. So while we wait for a key to be pressed, it is just going to continue to execute that. As soon as one is pressed, we will check to see what that button is in just a moment, but we have button character is where it will be saved as a value. Serial.println, tone, buzzer pin, we're going to print the frequency 880, and we're going to do it for 100 milliseconds. Now, that's just to let us know that a button was pressed. And then we finally go down to check what the heck was actually pressed. There's only two things it really could be, okay? Because there's only two things that initially you want it to be. It's either going to be the star if you want to enter a new pin, or this if you want to access the system. So let's say it was this to access the system. If it was that, then we're going to say Boolean access allowed equals validate pin. So here's where we get to the new function, return statement. This is essentially doing two things. It's one, setting this value to whatever this is going to be. But that's also essentially just checking to see if we are allowed to have access. And I'm going to guess validate pin is a function that simply allows us to check to see if we have access. And if you go down here to Boolean validate pin, that's exactly what we need to do. We need to enter the pin to continue. The default pin is 0, 0, 0, 0. So this first time around you go through, you'll probably be typing in each time you go through 0, 0, 0, 0. And this is exactly what you're doing in this for loop. For int I equals 0, I is less than pin length, I plus plus. Inside of this function, we're going to go through each time and we're going to wait for a key press, give a little tone input thing saying, hey, a button has been pressed on the buzzer. If the character they press is not equal to what the value of at that place in the current pin is supposed to be. So let's just say the very first one you decide to type in is 1. Well, that's not equal to the character of 0 that it's mentioned up here as a default pin. So what's going to happen is it's going to go down here and it's going to say, hey, that's wrong. This is not equal to it. So we're going to do this statement here. Here's where we get to the new thing. We're going to return false. You'll notice that this isn't void validate pin. It's not int validate pin. It's not nothing like that. Specifically, it is Boolean validate pin. And the reason that that's important is because that means that at some point in this code, we need to return, in order to leave this function properly, otherwise it's not set up correctly, we need to return a Boolean, which means at the end of this thing, we're either going to return true or false. It's going to be false if we inputted the wrong pin, meaning that we do not have the access or know how to access the system, and it will return true if we did input the right pin. So as soon as we input one of the incorrect ones here, we're going to immediately return false, and we won't continue any further. Otherwise, if let's just say we did go through this entire for loop and we made it just fine, and we didn't input anything incorrectly, we will return true. Now, you'll notice something is kind of off about this if you go and test this in your code. We left this in here for a specific reason, and that's that this pin here is actually easily brute forceable. If you're interested in learning more about this security flaw, I highly recommend checking out day 15, where we'll be going into more detail on how to remove this security issue entirely from the code so that no one should be able to brute force it by typing in random characters each time. So let's just say we returned false here, because we typed in 1 instead of 0 for that first character. If we hop up to the loop, we'll see if access is allowed. In this case, it's false. So we did not say welcome authorized user. We did not get to that point. We're going to jump to this else statement. We're going to say access denied. And it's going to tell us this exact same thing. Press the star to enter a new pin or the hashtag to access the system. And we can go through the same thing again. But if we did get it right, it'll go here. Now we have the other functionality, which is going to simply go and it's going to create a new pin. Obviously 0000 is a pretty bad default pin. I think most hackers would probably put that in like a short list to begin with if they're trying to brute force something, as one of them that is so commonly used. It's like password. If button character double equals the star key, then we'll do Boolean access allowed is going to be equal to validate pin. Now, if we want to change the pin, we're going to check to make sure, one, do we have access to change the pin? First, you have to input the old password before you can change the new password. If, and again, this goes down to the validate pin, we went over this a minute ago. Let's say in this case, it returned true. You got the initial pin. You typed in the character 0000, and you're able to change that default pin to whatever you want it to be now. It says, welcome authorized user, please enter a new pin. Finally, we go through, and we're just simply going to go through each of the loops, and we're going to say button character. We're going to wait for an input, play a little tone, and then we're going to set the current pin I is equal to whatever button we just pressed. So let's just say we want to set it, instead of 0000, we want to set it to A, B, C, D. Well, we can do that. We go through this loop. First time we go through, we type in A, sets the first one to A. Second time we go through, we type in B, sets the second one to B. In this case, remember, 0, 1, 2, and 3, because arrays always start at 0. Once it hits that length, which as we know is 4, is the final pin length, once we know that this returns false, it's going to exit the for loop, because obviously 4, once it gets to 4, is no longer less than 4, so that's false, and it'll exit the loop. And then it'll go down to here. and it'll say that the PIN has successfully been changed to whatever we had decided to type in. Else, we're going to say if we did not initially type in that first PIN, it's just going to not allow us to change the PIN, so we won't be able to continue any further. With that, that should be all there is for the logic for this day. Again, if you want to learn more about the security flaw with how we actually do the PIN validation, check out day 15. We will go into more detail on that there, on a good way that we can show how to fix that brute force vulnerability that is currently part of that, if you guys are interested. And with that, that'll be it.
Welcome to the Day 13 wiring example video. Today we don't have any new wiring or circuits to discuss. The hardware is all just the same as it was on Day 12. Instead, today we'll focus on the functions provided by our new software sketch. We are using our newly mastered keyboard and buzzer to implement a simple password security interface. Once again, we'll need to keep an eye on the serial monitor console to get feedback on how things are working. The rules of this security system are pretty simple. You must enter a 4-character password to gain access to the system. Also, you may change the password to something else, but in order to do so, you must enter the old password successfully. The pound key is pressed in order to request entry, and the star key is pressed to change the password. We'll be getting messages about success or failures of these attempts on the serial monitor. The starting default password is 0000, although you can change this in the sketch if you wish. So with this information in hand, let's go ahead and load the sketch and see how things are working. So going over to the IDE, we'll load our sketch. Uploading now. Done uploading. Okay, so we should be up and running now. And so we can go ahead and, for example, try to enter the system using the default password. So we should press the pound key, and I'm prompted on the monitor to enter the PIN. So I'll enter the default password, 00000, and the device is successfully unlocked. So that part at least works okay. Let's next see if we can change the password to something that's a little harder to guess. So in order to do that, I'll press the star key, and now I need to enter the old password in order to go any further. So I'll go ahead and enter 0000 again. And it's now unlocked, but now I need to enter a new password. So let's enter one that's almost as lame as the first one. 1, 2, 3, 4. Okay, I get a message that says that the PIN has been successfully changed. So let's go ahead and see if we can verify that this is the new password. So I'm going to press the pound key again in order to attempt to enter once again. So pressing pound, I'm prompted to enter the PIN. If I enter the old PIN, so for example, if I start putting in 0, it says, well, I didn't press 0, I pressed a star. So it told me that star was the wrong character to enter, so it immediately aborted the entry attempt. Let me try it again with a 0. So pressing the pound key. Now I'm going to enter 0, and 0 was wrong as well. Oh, I remember now. I changed the password. It's now 1, 2, 3, 4. So let's see if that'll work. So I'll go ahead and press pound, and then press 1, 2, 3, 4, and I'm successfully unlocked. And if I decide, well, that's really just too terrible a password to use, I can change it again. So I'll go ahead, press star, press the old password. So I've got the new password is 1, 2, 3, 4. Okay, so the device is unlocked. Please now enter a new password. So let's try something a little harder to remember. Let's do B987. So that's my new password, and I can check to see if that's correct. So let's go ahead and try and enter. Press the pound key. Now let's enter the PIN to continue. So that was B987, and that was successfully unlocked. So this seems to confirm that our security sketch is functioning as it was designed. However, if you've been paying close attention, you might have noticed that our security system isn't really all that secure. Can you see how a determined hacker might be able to figure out the supposedly secret password even after it's been changed? Think about this a little bit. And if you want to work on ways to improve this security, be sure to check out the activities on Creative Day 15. But in the meantime, we'll be looking forward on Day 14 to adding more hardware and software features to this system. So we'll see you then.
What an impressive day, Explorer. You've stepped up to the challenge and fortified your control panel like a true galactic defender. Just imagine the disappointment on the face of any rogue mothership attempting to hijack your controls. Delightful. I dare say our control panel is looking quite formidable. But wouldn't it be nice to add a touch of theatricality to it? Tomorrow we'll bring back our trusty RGB LED from last week. And to add more panache, we'll also integrate some code logic for our buzzer to create a symphony of auditory and visual feedback on pin input. Lights and sounds for every action. The perfect command center for a sophisticated space explorer. Take a well-earned rest now. Remember, interstellar conquering requires both body and mind to be at their sharpest. Sleep well and get ready to add more intergalactic glamour to your ship tomorrow.